everyone, I'm teacher EJ. Welcome to day 1 of daily check-in. Today we are going to learn equal aerial transformation, and I'm going to show you a past year question from NMOS 2019. So now in the following figure, the length of the side of square ABCD is 16 cm, and the length of side of the square BEFG is 12 cm. DE intersect BC at point P, and we are asked to find the area in centimeter square of the shaded region APEG. So now guys, do you ever learn the formula to calculate the area of such an irregular shape? No, right? But take a closer look at our shaded region again. Does it look like it's made out of some common shape that you have learned before? It's made out of two triangles. So now, what is the formula to calculate the area of a triangle? So it is base times height divided by 2. But guys, can we apply the formula to calculate the area of our triangle here? So the answer is no, because we don't have any information of any side of the triangle. But don't worry guys, let me teach you a very special model with an example here, okay? So now, we have two lines here, and these two lines has a characteristic which is the parallel line. So now, let me draw a triangle between these two parallel lines, and I'll name it ABC. Right, let me fix the base of the triangle at AB, and I'll move point C to point D, and I'll draw another triangle. Now let me ask you, what can we say about the relationship of the area for these two triangles? The area is the same. So we just know that the formula to find the area of triangle is base times height divided by 2. So now you can see that they clearly have the same base. And for the height, since AB is the base, so we can draw a line from point C to the base. So same goes to the point D to find the height. And since the two triangles are between parallel lines, so the height will be equal, which results to the same area. Now, let me give you an example here. I will move point C to point E, and I will draw another triangle. Now, let me ask you again. What can we say about the area of these three triangles? Since the triangle also have the same base and equal height, the area will also be the same. So we can see that we can move the point anywhere on the parallel line, and the area remains the same. The way we're moving the point is just like we're dragging the curtain at home. So we name this model curtain model. But guys, you have to remember the characteristic of the curtain model. You will need to have triangle between two parallel lines. One side of the triangle is on the parallel line, and the corresponding vertex is on another parallel line. So now guys, let's try to apply the curtain model in our question here. Since we have two triangles, let's try to transform the triangle on the left first. We'll need to find the parallel line. So what is the easier parallel line that you can find from a square here? Alright, it's DA and CB. So we'll need to fix one side of the triangle on the parallel line. So which point of the triangle should we move here? We move point A. And where should we move it to? We move it to point D. So initially we have the triangle GPA, and after the transformation, which triangle do we have now? The triangle GPD. But guys, can we calculate the area of this triangle GPD? The answer is no, because we still don't have any information of the triangle. But take a look at our shaded region here. Do you notice something happened to our shaded region? Wow, it became a big triangle now. Now, we mentioned that in the question, DE intersect BC at point P, which means DE is a straight line. So, can we calculate the area of this big triangle? So, although we cannot calculate the area directly using the formula, but there's another way to calculate it. Let me show you, okay? So now, what we can do is to try to calculate the area of the whole diagram and minus out the unshaded region. So the area of the whole diagram is just 2 squared. So we can use 16 times 16 plus 12 times 12, which is 400 centimeters squared. How about the unshaded region? So let's look at the big triangle. So the area is just 16 plus 12 times 16 divided by 2. And for the triangle on the right side, the area is just 12 times 12 divided by 2. And finally, we have a small triangle on the top there. So we know that DC is 16 centimeter. How about CG? It is 4. So we can just use 16 times 4 divided by 2 and we get 328 centimeter square in total. So to find the area of the shaded region, we use 400 minus out the 328. We get 72 centimeter square. But guys, what if the 16 centimeter is not given here? Can you still stop this question? So now, let me show you another way of doing this question, okay? So we can try to apply the curtain model again. So guys, can you find a parallel line here that can help us to transform our big triangle GED? If you cannot find it, don't worry. Let me give you a very simple example here, okay? So I'll draw two squares here that are side by side, and I'll draw the diagonal line. Now let me ask you, what is the angle of this part right here? So it is 45 degrees. How about this part? Yes, it is also 45 degrees. So now, let's say these two squares are put on the floor, which means these two diagonal lines are 45 degrees from the floor. So what can we say about the characteristic of these two lines? They are the parallel line. So now guys, where is the diagonal line that we have in our diagram here? It is GE. So how do we draw another line which is parallel to GE? Yes, it is DB. So now, how do we transform our triangle here? Which point should we move? Yes, we move point D, and where should we move it to? Point B. So initially, we have the triangle GED. And after the transformation, which triangle do we have now? So we have GEB. So now, to find the area of the shaded region, we just simply use 12 times 12 divided by 2, which is 72 centimeters squared. So some of you might wondering, what if we try to transform the triangle on the right first at the beginning? Can we do that? So the answer is no, it's not doable. So now, let's summarize what we have learned today. So we learned this model right here, which is named curtain model. So what do we need to have to apply the curtain model? So we'll need to have triangle between parallel lines. And how do we transform the triangle? So we move the vertex of the triangle and the area remain the same. Next, we learn that when we have two squares placed side by side, not only the opposite side of the square are parallel, the diagonal are also parallel. So now, you can try to do this practice question by applying what you have learned in this video. So remember to scan this QR code to join our study group and submit your daily check-in. I hope you enjoyed this video and don't forget to subscribe our YouTube channel. See you in the next video. Bye bye.